All right, the bonuses. The Mossy Creek Bottling Company produces cans of fresh cola drink, the volumes which vary normally with a mean of 12 ounces and a standard deviation of a half ounce. Approximately what proportion of cans of fresh cola drink contain between 11 ounces and 12 and a half ounces? So we won't do any of this until after Christmas. It'll probably be around February, maybe March. Hopefully in February we'll start looking at this thing. There's something out there, it's called a normal curve. It looks something like this. And it says you have what you call your mean, which I'll just call X bar for today. And within one standard deviation of the mean, you have 68% of this curve. So each of these are like 34 and 34. And so this would be X bar plus an S or minus an S. And this would be X bar plus an S for standard deviation. And within two standard deviations of the mean, you have 95% of the thing. So that makes each of these guys 13.5 and 13.5. So this is going to be X bar plus 2 standard deviations. And you've got 5% of the thing left to go. Let's see, you guys are going to do 68, 95, 99, 7. So these last little boxes, even though they're not drawn properly, are 2.35 and 2.35 respectively of the graph. And the tails are each 0.15. That's the one we teach you in Tennessee. So let's talk about our cola drinks cans here. And I wish I could make this bigger. It's just almost too small to draw it properly. But we have a mean of 12. And if we add a standard deviation, we'd be at 12.5. If we add another one, we'd be at 13. If we add another one, we'd be at 13.5. If we subtract, we have 11.5, 11, and 10.5. Now, I want to know what proportions of cans of fresh cola drink contain between 11 ounces and 12 and a half ounces. So I'm interested in this territory right here. So let's go back and look over here. This guy is 13.5. This guy is 34. And this guy is 34. And I just add those numbers together. 34 and 34 is 68. Borrow 10, you're at 78. Add 3.5, and it's 81.5%. Or maybe the decimal 0.815. One of the two. Not sure how it'll be answered. All right, anyways, that's how you do it. 27, which of the following is equivalent to 1 divided by root 3 minus root 2? There is this idea of a conjugate in mathematics. And the conjugate of root 3 minus root 2 is oddly enough root 3 plus root 2. It's just a sign change. You don't really see a whole lot of this anymore, even in Algebra 2. There's stuff like this isn't even allowed in Algebra 2 anymore. But what we're going to do is we're going to multiply the numerator and denominator by that conjugate. Let me do this where I have more space. They've really dumbed this course down, and I can't stand it, how much they've removed. A root 3 times a root 3 is 3. A radical times itself is number inside. A root 3 times a root of 2, is a root 6. Apparently I should have changed both of them. Oh, no, it's going to disappear. I'm being silly. A negative root of 2 times a positive root 3 is a minus root 6. And a negative root of 2 times root of 2 is a negative 2. And up top we have this. 1 times root 3 plus 2 is root 3 plus root 2. Now the root 6's cancel, and 3 minus 2 is 1. So it turns out it's root 3 plus root 2. with a thumb. That's what it looks like. And it looks prettier that way because it's not a fraction. And most importantly, there's no radical in the denominator. All right, 28. One of the zeros of f of x equals x to the fourth, blah, 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 is 2 plus I. What is the other zero? Or what is the complete set of solutions? So I just mentioned this idea of a conjugate. And imaginary numbers happen in pairs. You know, if you do the quadratic formula, like if you had 2 plus or minus root negative 4, both pieces over 3, you'd have 2/3 plus or minus, this is 2i over 3. Imaginary numbers happen in pairs, and we call those conjugates. The conjugate of 2 plus I is 2 minus I. Turns out I actually know 2 of the 4 zeros of this thing. And we're going to do a little technique called synthetic division, which you'll learn about in the next unit. This is something we do in Unit 3, although not with imaginary numbers. But this is a challenge exam question. This is called synthetic division. It's kind of weird. You put the 0 out front, and one of them is 2 plus I. And you're going to put the coefficients of the equation here. 1, -8, 25, -36, 20. We drop the first term, and then we multiply. 2 plus I times 1 is 2 plus I. And then we add down. -8 plus 2 is -6 plus I. And then we multiply. This is where kids kind of get thrown off, because you got to figure out what 2 plus I times -6 plus I is, which isn't that bad, especially if you're holding a TI-84, because you know it can do it. Since the imaginary number is not in your Algebra 2 standards this year, I'm not going to do this by hand with you. And I got -13 minus 4i. And then we add down. 25 plus the -13 is 12, plus the -4i. And then we multiply again. So here I have, and by the way, I could have just said plus 25, 12 minus 4i. We're going to multiply that by 2 plus I. And we're going to get 28 plus 4. And what I have to do is I have to add a -36 to that, because I add down, and I get -8 plus 4i. And then I multiply again. So times 2 plus I. I got -20. When I add down, I get a 0, because that was a 0. Therefore, it had a remainder of 0. And now I get to do it again with its conjugate. So this time when I do synthetic division, I'm going to keep these pieces. 1, -6 plus I, 12 minus 4i, -8 plus 4i, and outside is going to be its conjugate, 2 minus I. We always drop the first term, and then we multiply, add down, it's -4. We multiply, 2 times -4 is -8, -4 times -I is plus 4i, add down, I get 4. 2 times 4 is 8. 4 times -I is -4i. Add down, I get a 0. So what you've done is you've actually divided 2 known factors or solutions out of the original equation. And this is your remainder. This is the constant. This stuff right here is what we call a quotient. This is an x, and this is an x squared. Since I want the last 2 zeros, I take this stuff right here, and I set it equal to 0. Now, the thing that's been created doesn't factor. Yes, it does. I'm just being slow. No, it doesn't. Yes, it does. It factors as x minus 2 times x minus 2. Negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. And that's equal to 0. So by the ZPP, my last two answers are 2 and 2, because it's a repeated solution. It's where you touch the x-axis, by the way. That was a lot of fun. All right, what is the solution set of the inequality x plus 1 over x minus 2 is less than or equal to 1? This really isn't that bad. One thing I know that I can't do is I can't divide by 0. It's called domain. So I know that x cannot be 2, because if x was 2, the world would end right there. So x is not going to be 2. That's not going to lie in the solution set. So what we're going to do is we're going to clear the fraction. To clear the fraction, you multiply both sides by whatever the denominator is, and then you go to town on it. Cancels on the left. So x plus 1 is less than or equal to x minus 2. What a funky looking thing. The reason I'm saying that's funky is because that doesn't have any known answers. So that may not have been the best way to do that. Very smart of them. They gave us something that is not easily done with algebra. Okay, so plan B is look at a graph. There's lots and lots of ways of doing this. Some old school techniques are to make tables, but I don't feel like doing any of that. You got x plus 1. 730 over x minus 2. 6:51. I've still got to get stuff ready for class today. Still got to do some prep for ACT prep. And at y2, there's a 1. And we're going to hit zoom 6. Now, do remember I said x couldn't be 2. All right, well, this isn't so bad. It really is not so bad. It's actually kind of a nice one. That 1 is actually servicing is what we call a horizontal asymptote. So this isn't so bad. So let's look at this in the context of what it's asking. And remember, the x plus 1 over x minus 2 was the blue graph, and 1 is the horizontal line. It's literally saying, in layman's term, is where is the blue below the red? In layman's term, that's what it's saying. Where, or your x values, is the blue graph below the red graph. So that's happening around here. This, by the way, is that value of x you couldn't be. It's actually a vertical asymptote. And those aren't drawn by calculators. But so long as x is less than 2, this is true. So the answer to this thing would be x is less than 2. I can't use equality because I wasn't allowed to be 2. Or if you like interval notation, negative infinity. See how many tries it takes for me to get the infinity symbol to show up. The first time to 2. Interesting. Is that an actual answer that's listed? Don't know. There's 29. 31 in geometric sequence has the first term ace of 1, and the fourth term ace of 4 is 4. What is the sum of the first 6 terms? So I haven't talked about a geometric sequence with y'all. It's supposed to be talked about in Algebra 1. It may not have been. But a geometric sequence moves from term to term with multiplication of the same number, and it's called R. And the nth term of a geometric sequence, called a sub n, is the first term, a sub 1. I don't even know if we need this formula for this, times r roof-topped to the n minus 1. But anyways, that's just stuff about it. But here's what I know. I know the first term is 1 and the fourth term is 4. All right. First term is 1, 2, 3, and there's a 4 here at the fourth term. And I want the sum of the first 6, so I'm just going to go ahead and find the first 6. And I don't really need this thing. We can just do it recursively. You know, what do I multiply by so this happens? That's a good question, isn't it? It's actually a very good question. It's not 2. I guess I'm just having a senior moment here. It's a fraction. Bummer. Okay, so it turns out that I might actually want to use that thing. So let's plug into this thing. First term is 1. Now this is the, fourth term? This is a sub 4. So 4 would equal the first term of 1 times the ratio. And if I'm at a sub 4, n is 4 cubed. It's the cubic root of 4, isn't it? So the ratio is, the opposite of cubing is cube rooting. The cube root of 4. What a hideous question, man. I see it now. I didn't see it before. Okay. So anyways, 1 times the cubic root of 4 is going to be the cubic root of 4, and this is not the square root. What's the cubic root of 4 times the cubic root of 4? What's the cubic root of 16? If you do the cubic root of 16 times the cubic root of 4, you get the cubic root of 64, which is 4. So that's why it was working. The next term is going to be 4 times the cubic root of 4, which is 4 cubic roots of 4. And the term after that is going to be 4 cubic roots of 4 times the cubic root of 4, which is 4 cubic roots of 16. And this, boys and girls, is why kids hate mathematics. It's exactly why they hate them. Anyways, we're supposed to add all these things together. All right? It's all supposed to be added together. And it's not going to be a very pretty answer. I wish it was. But you're supposed to find the sum of those two things, all that stuff. You know, some of this stuff we can do pretty easy. You know, 1 and 4. Does that make 5? I believe it does. Let's see. These guys are alike. You take a cubic root of 16 and 4 cubic roots of 16 and put them together, you get 5 cubic roots of 16. And these guys are alike. 1 and 4 makes 5, so plus 5 cubic roots of 4. And I really don't think we can clean that up much more. I could be dead wrong on that, but that's your answer. What a hideous looking problem. The points a equals root 3 over 2, 1/2, and b equals negative root 2 over 2, positive root 2 over 2, both lie in a circle whose equation is x squared plus y squared equals 1. What is the length of the longer of the two arcs of the circle having a and b as endpoints? So this is actually what you call a unit circle. And none of you probably remember this because for some reason kids just forget everything. That is the standard form of a circle. H and K is your center. So this guy right here is x minus 0 squared plus y minus 0 squared equal to 1 squared, because 1 squared is still 1. It is centered at 0, 0, has a radius equal to 1. And she looks something like this. Now, it'd be really cool if you guys remembered things from geometry. like 30, 60, 90 and 45, 45, 90 theorem, but you don't, which kind of sucks, but it's kind of a prereq for this class, for this question. The reason I'm mentioning these things, like here's a 30, 60, 90. The pattern you guys were taught was x, 2x, and then x root 3. You can do better than that. If you let the short leg be a half, then the long leg is root 3 over 2, and the hypotenuse is 1, which makes sense on the unit circle because the unit circle has a radius of 1. So if I go over root 3 over 2, and then I go up a half, this would be a 30-degree angle. All right, and that's A. B is negative root 2 over, comma, root 2 over 2, which is actually over here. And again, I talked about it'd be cool if you guys remember things. Kids, a lot of kids are like, Milbrath, I was good at geometry. No, you weren't, son. You weren't good at geometry. If you don't remember this stuff, you weren't good at geometry. You kind of just managed to get through the class. So here's a pattern from geometry. It's 1, 1, root 2, or x, x, x root 2. That deals with the 45, 45, 90. If you make the hypotenuse 1, it turns out that these lengths are root 2 over 2. So when I see these numbers, I know that there's a 45-degree angle that's been formed with the x-axis. This is point B. So what is the length of the longer of the two arcs of the circle having A and B as endpoints? Which arc is longer? Oh, wow, this thing got way harder. So there's two arcs that can have A and B as endpoints. There's this guy, or there's this guy, and this is definitely the longer one. This is the longer arc, no doubt about it. That arc has a semicircle of 180 degrees, and it has 45 here and 30 here. In degrees, the arc contains 210, 255 degrees. So the measure of major arc BA or AB, and it is a major arc, is going to be, what did I say, 255? Yeah, 255 degrees. Now, they want to know the length of the arc. A full circle is 360. So it's 255 out of 360 degrees times the circumference of the circle, because we're talking about the length of the arc. And, you know, the formula for circumference is 2 pi r, isn't it? Well, the radius is 1, so the circumference of the circle is twice pi. So I'm thinking it's 255 over 360 times twice pi. And I just kind of simplify things. 2 over 360 is 180, so 255 pi over 180 units. And that'll actually reduce some more. 255 and 180 have got to be divisible by 5. 20. It's me over 36, yeah. If you divide 180 by 5, you get 36. I don't know why that took me so long. If you divide 255 by 5, what do you get? And again, I don't know why it's taking me so long this morning. 51. So 51 over 36 pi. That's the longest arc length. All right, 33, the function f of x equals 3x plus 2 over 4x plus 3 has a domain, all values of x such that x is not negative 3/4. What is the value of f to the negative 1 of x? What they're asking you to do here, and it's written poorly, is they're asking you to find the inverse of this thing. And inverse is something we'll be doing sooner or later. But there's A couple of steps in writing an inverse. F to the negative 1 of x literally means find inverse. And an inverse is the opposite function. And inverses swap x and y. They swap input and output. They do the reverse thing. So our first step is going to be to swap x and y. Our second step is resolve for y. Our third step is replace y with f to the negative first of x. And I'm sure by now most kids have tuned me out. But f of x is fancy for y. We're literally going to get the f out and call it x. And everywhere we see an x, we're going to make it a y. And I have to write this out because I can't type it out. Next step is going to be to clear the fraction. So I'm going to multiply both sides by 4y plus 2. I'm going to invoke the distributive property. 4yx plus 2x is 3y plus 2. I'm supposed to resolve for y, so everything with a y is going on the left. And everything else is going on the other side. This is going to come over. 4yx, 2 minus 3 is negative 1, minus y is 2. Factoring is my favorite F word. I'm going to pull a y. I'll have 4x minus 1. And now I can solve for y by doing division. You know, a handful of you should realize that I've been asking you to do this kind of thing on your basics quiz. I have been. I've been setting that idea up of how to factor. And now I replace y with the correct notation. The inverse of the original function is 2 over 4x minus 1. All right, 34, we have logarithms. If log base 2 of x is equal to log base x of 4, what is a set of possible values of x? And you guys haven't seen logarithms yet. Logarithms will be a topic we talk about in January, late January maybe. It's coming at some point in time. Here's how you do this. You guys just, it's too early for me to describe what this is saying. But you're going to use something called change of base. So a logarithm of some base b of argument a is equivalent to what we call the natural log of a over the natural log of b. So this guy becomes ln of x over ln of 2, and it's equal to the ln of 4 over the ln of x. All right. What good does that do you? It does you some good. I'm trying to think if there's an easier way to do this because I'm trying to get it so that you guys can just use a calculator on this problem. There probably is a more easier way to do this by hand, but you just don't know anything about logarithms. So for today, this is your best shot at getting it. Let's see what we can do here. We can do y1 and y2, can't we? I don't know why I put so many bonuses on this test. Let's go to math. Let's scroll to num. Let's go to n over d. Here's the ln key. ln x, ln2, and y1. y2, math, num, n over d. ln4, sitting pretty over ln x. Let's see what the TI-84 says. Zoom 6. Graphs of logarithms look kind of like ours to some degree. And we have two answers, don't we? We have two intersections, one there, one there. So second, trace 5 for intersect. Get your cursor close, enter 3 times. Enter, enter, enter. There you go, 0.3752. So see that one, 0.3752. Second, trace 5. Get close to the intersection. Press enter 3 times, 1, 2, 3. Here's the other one, 2.6651. That's your answers. All right, each spring, Jessica, Sam, and Michael work together to score the TMTA high school math contest exam. Some of you guys have been to that test, that contest. It's at UTM every year. If Jessica and Sam work together, they can finish scoring in 2 hours. If Jessica and Michael work together, they can finish in 90 minutes. Sam and Michael are the slowest. If they work together, it takes 3 hours to finish. How long would it take if all three of them worked together? This is a challenging little problem because it's a work problem. So it's a very rough little problem. And I wish it was as easy as saying J plus S equals 2 and J plus M equals 1.5. S plus M is 3. But it's not. It's not that easy. And if I remember right, there was no correct answer on this one, because the author of the question didn't do it correctly. So that one needs to be omitted. Like I need to pull it from the test. That one doesn't have a correct answer. And cool, I'm done. About time. Still got a lot to do. Anyways, there's the bonuses. Probably I'll have 3 or 4 views on that. Ain't nobody gonna watch that video. Later.